very pleased to introduce our presenter today, Mike Amundsen. An internationally known author and speaker, API strategy advisor Mike Amundsen travels the world discussing network architecture, web development, and the intersection of technology and society. He works with companies large and small to help them capitalize on the opportunities provided by APIs, microservices, and digital transformation. Amundsen has been an API advisor and architect for MuleSoft and CA Technologies, along with other leading tech companies. Take it away, Mike.
Thank you very much, Haley. Thank you. And it's great to be here. I'm sorry I can't see everyone. I was really looking forward to being with you directly, but I'm very happy to be here, and I'm hoping we have a great session today. I'm very excited to bring to you this idea about empowering your company and this notion of digital transformation. And I was really looking forward to bringing it home and making it tangible. So what I'm going to do here is I'm going to just pull up my slides so we can go ahead and go through these slides together and talk about this notion of transformation and APIs. So first of all, as Haley mentioned, I used to travel a lot. Now I travel virtually, but this is the best way to get hold of me. This is how you can find me on Twitter and LinkedIn and YouTube, and I would love to connect with you. I would love to learn what you're working on, what your challenges are, and how you are meeting this notion of digital transformation in the current age. I also want to say that most of the material that I'll present today is from an extended report that I wrote for O'Reilly about a year ago. It's called API Traffic Management, but it's really about APIs and how APIs transform your organization. And it's really about what you can do to improve your own performance, your own software architecture, your own monitoring and management of your future. So you can pick this up. There'll be a link in the slides at the end, and you'll be able to see it. I also wanted to mention that I and some colleagues are doing the second edition of a book called Continuous API Management. This is much more of a deep dive into the details of teams and technology, individual API, step-by-step management, as well as landscape and platform management. If you really want to dig deeper, this is a great place to start. Okay. So I want to talk about a handful of things. I want to talk about this notion of performance imperative. So much today has to do with actually meeting customers' demands, meeting their expectations, being where customers want to be. So we'll talk about that. And then after we talk about that imperative, I want to talk about 3 ways that you can start to focus today on changing your relationships with your customers, both upstream and downstream, to better meet those performance imperatives. Architecture, monitoring, and managing, and hopefully these will make sense. Now, also along the way, I want to actually interlace a project that I had been working on for MuleSoft, but it's really what I call the 4 M's of monetization, marketplaces, and APIs. Some simple ways to think about how you can apply these sort of technological or conceptual elements to your everyday activities, and also make sure that you can focus on the things that are important. APIs and transformation only make sense if they're improving your relationship with your customers, improving your bottom line, improving your ability and your team's ability to creatively solve problems. APIs for API's sake is just not worth it. It could be very expensive. It's not something you want to jump into unless it's actually giving you some great benefits. So let's just start by talking about this notion of the performance imperative. Things are changing massively. Even before we had to deal with the pandemic, we had to deal with this notion of IT transformation, of digital change. Every organization is now an IT organization, is the way the phrase goes. But especially now that many of us are working remotely, that so much of our connections happen through IT, that happen through the internet and through the web, it's really important to think about these. And from just a direct standpoint, just a direct customer standpoint, API call volumes, or the actual activity of APIs, is going to continue to increase at an exponential rate. And at the same time, we need to make sure that we can respond to customers both in real time and just in general in a really effective way. So IDC has done a report, and they basically said that modern enterprises are leaning more and more to this notion of using APIs. APIs are really just the highway, the connection, the way to connect one organization to another, one person to another. We use APIs every single day. And enterprises are starting to actively manage and promote their API platform to help actively manage and promote their connections. And a lot of these APIs are also being implemented through these things called microservices, which are really just smaller implementations of services, that the same ones that we've had before. APIs are this layer on top of a service infrastructure. Many of my customers have a very powerful, very robust API platform, or service platform. What they don't have is an easy way to connect those services, and APIs do that. Often you don't need to rewrite your software. You've got decades of intellectual property tied up in that. What you just need to do is add an API so that you can make them easier to access. So call volumes, what does this really mean? It literally means the dependency you have on your software and getting your software into the right place at the right time. APIs allow you to distribute information, distribute status to other places in a way that's relatively inexpensive once you get that initial investment built. So the virtual world, the virtual highway, and we're going to see more and more volumes go up and up and up over the next several years. And at the same time, most systems expect very fast results in the tens of milliseconds. That's a huge demand, especially as your global reach expands, as you begin to create more and more connections around the world. Just the very connection that we have here, this is an amazing thing that we're dealing with every day. The good news is these platforms exist, whether it's our big marker platform here or any other platform. The same platforms exist for APIs, and they can exist in the cloud or they can exist on premise. So it's a matter of thinking about how you can start to use these APIs to meet the performance expectations of your customers. Customers want information now, they want information at the ready, and they want information where they are. So that's really, really important. 90% of companies are going to be supporting these microservices through APIs. 80% of the respondents to the IDC survey think that they're going to be looking at more than 250 million calls a month. And that means that they need response time that's really slow. So it's a huge challenge. The good news is most of us have all the technology we need to solve this problem. We just don't have the experience, and we don't have the perspective. And sometimes you can hire that experience and perspective in. You can bring people in to help you get your feet on the ground and get started. And sometimes you can grow that internally. So the real question is, how do we meet these demands? Customer expectations, volume, and response time. The first step along this journey is to actually make APIs, to actually create and construct these connector bits between your existing services and some other place, whether it's another partner, another customer, another platform. That's really the first step. And the important thing to keep in mind is making APIs is not writing the code of the service. It's merely writing the connective tissue. It's the connections between the two. So we have this notion of committing to using APIs as connectors. Often, especially in a partner ecosystem, we have a devoted process for integration. And integration is not the way APIs work. APIs are a much more lightweight experience. You can think of APIs as a peer-to-peer relationship. You can think of integration as a supervisor and a supportive relationship. We're creating peer-to-peer relationships. This has huge implications for whoever is acting as your partner or whoever it would be whenever you're a partner as well. In other words, you're no longer subservient. We're now peers. We're working together and collaborating. That's a big mind shift, and that's a big attitude change. When you create APIs, what you're trying to do is enable people, but possibly people you've never met, to solve a problem that you may not have thought of. That's a big idea. It's no longer solving someone's exact problem. It's giving them the tools to solve their own problems using your information, using your APIs. That's what a good partner does, right? It's a collaborative effort. So how do we go about doing that? How do we start making this real? So architecting performance means that I need to start thinking about changing the way my IT infrastructure operates, the way I connect things together, and the kinds of relationships that I set up. So there are several things to talk about. You hear about this idea of lift and shift, but we're going to talk about the notion of rethinking services, rethinking our data, and re-engineering our network. So this notion of lift and shift is not enough. I can't just simply move my database from my on-premise to the cloud, or move my my commercial off-the-shelf software from on-premise to the cloud. That is not going to work. What we have to do is you have to be much more strategic. You might even say surgical about what you change and what you do different. You're going to add distance whenever you start to move things to the cloud. That's just the way it is. We know we can take care of this distance. We can mitigate this distance because I'm working with you right now directly in real time. So we know that's possible, but that's a different kind of engineering. The rules that cloud and native applications work under, even when you host them locally, are very different than the rules that mainframes or minis operate under. And that's an important element. So that means when we start to implement services, new services in our system, we need to make them smaller. We need to actually introduce just treat a feature as a service, a small element, a small change in the system. We need to think about reducing the time it takes. A lot of times we do batch jobs or other things. Our customers are starting to say, we don't want a batch job, we want an answer right away. So that means that I have to rethink the idea of how much time somebody has to wait in order to solve a problem. And the big change that's going on is that as we start to re-engineer our system, we actually need to re-engineer the notion of repair and recovery, of reversing changes in case they don't work correctly, and recovering from errors in real time. This is something we didn't have to do before. If you run a shop where you update your system maybe 2 or 3 times a year, you have everything works towards this one moment where you flip the switch and you do an update. Now we have many customers that update every 2 weeks. I have a few customers that update multiple times a day in production. That's a very, very different model than what we typically see today. So that's another way that we need to redesign the way we do services. Same thing goes for data. Often data is actually our gold. Data is the value exchange. Most of you have information about interactions between partners and customers that no one else has. And that's a huge value to the system. But that means you need to have that data in the right place at the right time. Often you need to cache data. You need to store data in another location closer to the customer or closer to the partner. Your partners in Brazil may need a content delivery system in Brazil, and you need to update that data. So staging copies of that data in various locations becomes important. Streaming rights. So when we need to save a lot of data, what you need to do is send it to a central location and it will get sorted out later. We have this notion of eventual consistency that we need to deal with. The idea of single source of truth or system of record is morphing into multiple systems of record and multiple sources of truth that need to be reconciled. This is exactly how we work in real life. This is how I get my news, my newspaper, my magazine, my online. I reconcile all those things. There isn't just one single place that I look, and this is the same thing that we're going to have to deal with in the IT world as well. Finally, that means rethinking the way we use the network, the way we use the internet, the web, the actual infrastructure that we have today. For a long time, we've been focusing on large-scale messages that are shipped reliably from one place to the next. Now we need to start focusing on small-scale messages that are shipped over and over again, just like this stream of video is. So that means rethinking the way the network is built. The network has to repair itself. It has to, we all have those experiences when the network is down and it can be very fatal. So we need to work around that. We need to have alternatives. We need to increase the number of messages, decrease the size of messages. And that means the return of remote procedure calls and all these other sort of classic forms of computing from 20 years ago. What goes around comes around. So architecting for performance is this notion of focusing on what's different about IT today, redesigning services, engineering data, and rethinking the network along the way. So that's a lot. But once we get started on this journey, and it is a journey, a step-by-step journey, we can start doing things differently. We can start managing the work that we're doing. And that's really stage 2 of an API ecosystem. Once you have this notion of understanding where data is, what traffic is like, what your services are doing, you have the opportunity to start managing an ecosystem of your services. It's no longer about one API or one service. It's about the collection of services. And as you begin to build out your APIs and incorporate other people's APIs into your system, you start to realize that what you're really doing is sort of managing a landscape, a kind of garden of services. And you need different kinds of plants in that ecosystem. You need different kinds of gardening methods, and they all interact with each other. So this is a really important next stage. It's one thing to start building APIs. It's another thing to start building the platform of APIs, where there are lots of APIs in the system. And APIs will be at various stages. Some will be brand new, some will be 10 years old. And you're going to have to manage an ecosystem where these technologies all live side by side. It's not going to be a monoculture. It's not going to be like farming. It's going to be more like gardening. And that's an odd metaphor, but I think it's an apt one. So fine, so we have this notion of we're building up our API ecosystem. Now we need to start paying attention to what it's telling us. Our ecosystem tells us what's working well and what's not working well. And we need to arrange our information system internally to take advantage of that. And we need to pay attention to 3 key elements of our performance. The infrastructure itself, which is typical, like are the servers running, is the network available, so on, stuff like that. That's really just the entry level element. The next one is, are the services that we've created or the services that we've purchased and that we're hosting, are they healthy? Are they doing what they're supposed to be doing? Are they giving us the return that we need? And then finally, at the business level, are we invested in the right services and the right technologies to move our business ahead? We have OKRs, we have objectives and key results. What can you tell me that APIs and services are doing to make sure that those results are being met? In other words, we need to justify every step along the way. If you have an API that is not meeting the business goals, you need to improve that API or remove it, because we don't have any time for just technology. It turns out this combination of your business metrics, your services metrics, and your infrastructure metrics all come together in one location. Establishing the key results, establishing the key performance indicators through your system, and then matching those up to make sure that you're meeting your results is the key to managing your API ecosystem. And one of the advantages that we have in this virtual world is that APIs are easier to monitor, easier to create metrics for. It's easier to see what the transactions are, which of these transactions are erroring out, which of these are not, which of these are actually providing new business, bringing in new revenue, reducing costs, which ones are not bringing in revenue, which ones are increasing costs. You have more information at your fingertips than you can imagine. And that's really, really important in this process. So managing machines and network connections and CPU and memory and bandwidth and saturation, classic IT material, that's all available. And making sure that you're healthy and making sure that you have the bandwidth that you need to meet your customers' response times is really important. At the same time, if you have microservices or ESBs or any kind of infrastructures or gateways, you're looking at latency and error rates and limits and all sorts of other things inside your services. You need to make sure that your services are running the way they're supposed to. Do I need to be running extra copies of this search service in order to meet my customers' demand? This is the seasonal time of year. I need to spin up a lot more shopping support services or a lot more order management services. I know I'm going to be doing a lot of deliveries in the spring, so let me make sure that I fire up the right number of services for that. You have the power to do this, and your service monitoring will tell you whether or not you're meeting it. Finally, what are your real business goals? Do we need more users? Are we supposed to be doing more transactions? Do we need to increase the sales volume per customer? Do we need to just increase customers? What is our status on completed orders? How long does it take us from the start of an order to a completion of an order? If it takes us 10 days, can I reduce that to 9 and realize that revenue faster? We now have, with this IT infrastructure, all the kinds of information we need to pay attention to these kinds of things. And that's super, super important. Oops. So that leads to another major step in your API and services platform. And that is the ability to possibly monetize the APIs that you have. Monetizing your APIs is different than using your APIs to support your existing business. Monetizing APIs is an opportunity to create new markets and new opportunities that you might not have seen before. So a monetization platform is one that takes advantage of all of that management information that I just talked about and makes it real. And there are lots of ways that you can do this, and it depends on your customers and your activity and your place in the market. You can, for example, start to analyze customer activities. If you're a major partner in the distribution chain, you know about both consumers and providers, and you know how they match. You can start to tell consumers what's advantageous right now. You can start to tell providers what consumers are looking for right now. You can often have an opportunity to see what's ahead faster than producers or consumers do. And that's a huge advantage. Now that's maybe analysis information. Maybe there's just direct sharing information about the number of transactions, the number of orders, the number of hard goods investments, the number of big purchases planned, and so on and so forth. You now can share that information as well in some cases. In other cases, you can simply use this strategy to reverse monetize your own platform. In other words, we notice that users are matching these three things together in our IT platform to solve a problem. Let's create a new product that just solves that one problem. And that reduces our cost, our maintenance cost, focuses on our customers' needs, our consumers' needs. So you can start to what I call reverse monetize, or simply reduce the cost of infrastructure, reduce the cost of management, and create a larger gap between price point and cost point. So there's lots of possibilities in this monetization space, and that happens once we've created our ecosystem of APIs that we can create. And that leads to the next level that's really important, and that's managing your entire ecosystem for performance. And this can be really, really important. So managing for performance is not just trying to make sure that we get the transactions out the fastest, or that we solve all the latency problems. It's actually getting insight into what's going on inside your ecosystem, insight into what's happening in your organization, with your consumers, with your producers. And that also gives you an opportunity to start using your IT platform to solve problems. If you know that you're seeing lots of errors in a particular part of a system, if some systems are aging out, if some of the off-the-shelf software that you have is no longer meeting demands, it's starting to fall outside service level agreement space, you can start to solve those problems before customers see those problems. You can start to add more services, add more instances, switch out products, change technology in order to focus on the kind of technology that's going to be really important for your customers. And finally, you have this ability to start anticipating their own needs, start to figure out what they're going to need a year from now. We know from telemetrics from last year what happened at this time of year. Let's prepare now. Let's start to give our customers what they need before they even ask for it. So this becomes the real sort of golden standard for why an IT digitally transformed organization can be successful. So you can get insight by monitoring what you're doing, but you can also start to solve problems in things like access control and security, scaling services in the right manner, diagnosing errors that are occurring inside your system. Some of these errors may be your own problem, but some of these errors may actually be the result of customers using your products in ways that you hadn't expected. You can help them out. You can reduce their frustration and help them better solve their own problems. And finally, you can start using this metrics, these dashboards, this information to start recovering from errors before anybody even knows it. You can notice, like a weather report, things are getting pretty bad in the Northeast. There's a lot of traffic on these servers. Let's spin up some more servers before there's a failure. And another big element, and this is a bit far down the line, but it's important, is this notion of experimenting within the system. In IT, it's called chaos engineering or system reliability engineering. It's the notion of actually starting to test your own system and break it in tiny ways in a controlled fashion just to see if you really are as resilient as you need to do. This is actually what Netflix does all the time. They manage this sort of chaos. So monitoring traffic is really important. We talked about this idea already. Managing what you have, knowing where traffic is going. But it's also turning this inward, monitoring your own performance, your own team's performance for builds and tests and deployments. In other words, you can start creating metrics on your own organization. And this means these insights get to be displayed on dashboards. This is what our traffic is like. You can sort of imagine the way air traffic controllers work. This is exactly what they do, right? They display the traffic of their system so that they can anticipate problems along the way. Dashboard culture is really sort of the next level of checklist culture. You might have read about checklist culture. There's a great book on checklist culture. Checklist culture was introduced when things got so complex, it was difficult to keep everything in your head at one time. Dashboard culture takes that to a new level, especially those of us who need to manage and make key decisions about the organization. It's too much to keep in your head. What you want is a dashboard that gives you close to real time or can play back history and start to tell you what's really going on inside your organization as much as outside your organization. And once you have this dashboard culture in place, you have this opportunity to start creating a whole new set of problem solution solvers. You can watch security happen in real time. You can see what's going on. You can scale services in response to what's needed at the moment. You can actually start to diagnose errors. You can see where situations are not going well, and you can make changes. So these dashboards now become your eyes and ears, and they become your alerts. They become your opportunity to reach in and make a difference, even before customers can tell. And then finally, it's this notion of anticipating needs. And a big one is automating recovery. When machines go bad right now, a lot of times what happens is you get a message that's saying, this machine's going bad, you're gonna need to replace it. In organizations that have already performed this kind of digital transformation, there is no alert that a machine is going bad. The system automatically spins up a new instance and replaces the bad performing machine. This starts to automate recovery process and literally hides the failure or prevents the failure from spreading widely through the organization. And it's also this notion I talked about running experiments. For example, Google and Netflix run these ideas where they take a sample of traffic and they actually alter the traffic in a way in an experiment to see, to make sure that the system is resilient and recoverable. They can do this in test. They can even do part of this in production as well. The idea behind this is to actually anticipate problems before they really even become an issue that's noticeable. Okay, so now we're talking about a completely different level of digital transformation. And that digital transformation is what I refer to as marketplacing of APIs or managing markets. So it turns out eventually when you are at the nexus of consumers and producers, you're in what's called in Silicon Valley a two-sided market, right? You actually have an opportunity to serve both ends of the market in really unique ways. And the good news is you get to monetize both ends of the market. You can offer things to consumers to help them improve their experience, and you can offer things to producers to help them improve their experience, their ability to match with consumers. So all of the big hit Silicon Valley projects of the last 5 to 10 years have all been based on two-sided markets, whether it's Uber or Airbnb or all sorts of other services like this. And that is matchmaking or market making. And you're in the same position as well. As you have partners, they have needs, you can actually join partners together, you can work as teams, and you can get this opportunity of creating a brand new market space all on its own. And that's a really, really important opportunity. That means that you get to see an even larger picture. Now, one of the things you might have noticed as each of these stages I've talked about, you start out very close to the technology, very close to the API, that's making APIs. Then you start to step back into the landscape, that's managing an ecosystem of APIs, governance of an API marketplace. Then you back up into the notion of business connections to APIs, and that's monetization process. Now we're backing up into marketplacing, or this notion of two-sided markets of this global API space. Each one of these opportunities stretches your horizon further and further along the way and gives you an opportunity to anticipate. And that horizon, that distance, also gives you time to think and time to experiment. You're no longer just solving today's immediate crisis. You're moving further and further and back, and your horizon gets bigger and bigger and bigger. And you can think more clearly and more creatively about your organization, its place in the system, and the opportunities that you have ahead of you. So let's kind of wrap this up a little bit, and then I'd be happy to talk at length about what I'm bringing to you here and what we can see is happening for you. So we've talked about this notion of performance imperative, architecting, monitoring, and managing. So we need to prepare for API volumes to go up and transaction time to go down. From the very literal sort of technological point of view, the real key here is to improve the technology that you have and your ability to meet the demands of your consumers. That means re-architecting things differently, thinking about how services can be redesigned and redeployed in smaller units, re-engineering the data so that it's where it needs to be. That means staging copies and keeping those copies in line and in sync. It means rethinking how you use networks. Networks add distance, so we need to add other things like cached copies, placed servers, all these other things in order to make sure that you're architecting for the performance that you need. Once you do that, you need to be monitoring not just your infrastructure, not just your CPUs and your memory and your machines, but you need to be monitoring the success of your individual services and how they interact with each other, how they interact with customers, and how your business metrics fit in. Which of these services is worth doing a version 2? This service doesn't offer us any more revenue. This service does. I'm going to invest my next version into this service, and we'll just leave this one alone. I'll just maintain that service as is. So it's starting to monitor what's going on inside your organization and helps you make decisions about what's the best effect. And then finally, this notion of managing for performance. So insight, problem solving, and anticipation. These are the long-term strategies that make a difference, that make any business work properly. These steps, insight, problem solving, and anticipation, used to happen in boardrooms with lots of thick reports and lots of paperwork. Now it's starting to happen in real time in organizations, in dashboards. And it used to happen with just a small collection of people in that boardroom. Now it can happen with hundreds and hundreds of your own employees who are looking at the same dashboards you are, who are able to anticipate, who are able to solve problems even before you even know about them. That's what a digitally transformed organization does. It unleashes not only the value in the monetary value inside your company, but unleashes the creative value, the collaborative possibilities inside your organization. And that's really the way to think about it. You know, in closing, I want to mention Warren Bennis. This sort of ages me out a bit, but Warren Bennis was a fantastic business writer and thinker for decades. And I love this quote from Warren Bennis from the 1980s and 90s. In life, change is inevitable, but in business, it's vital. There's a corollary to this, which basically says, adapting is not required for a business, but it is if you want to stay around. Change is vital, and organizing your business around this notion of transformation itself gives you an opportunity to make change a feature, a part of your organizational culture. And that means that you can take advantage of it. There's another great line which basically says, the only advantage you have over another company is your ability to learn faster. And that is dealing with change, and that is dealing with transformation. So hopefully this is interesting. I will you have copies of these slides. I will make sure that you have copies. You can read more about a lot of the material I talked about here in the API traffic book. You can download a copy of this free, and you'll get this in the slides as well. Hopefully this has been interesting. It's given you some ideas, and I'd be happy to talk more specifically about how you are experiencing IT transformation and services and APIs and how it might be able to help you. I've actually ended a little bit early, so hopefully we'll have some time for Q&A, and that's my presentation. I want to say thanks.
All right, awesome. Thank you, Mike. That was fantastic. So we are going to start the Q&A, but before we do, Mike was kind enough to share his presentation with us, and I just shared that in the handout section, so you should be able to see that there now. And then while we're in this Q&A, it looks like we have a couple of questions in the chat already, but in case you'd like to ask a question out loud, you can use the raise hand function and I will call on you. The raise hand function can be found at the bottom of the chat. And when I call on you, you'll go from view mode to interactive mode, and you'll need to unmute yourself to speak. So it does look like we have a couple of questions. The first one coming from Phil Bratt on our Synergex support team, actually. And the question is the checklist culture book you mentioned, the checklist manifesto, how to get things right?
Yep, that's the book. That's the book that I have. I found that to be a great book by Gawadny, right? I think it's a great book. Yeah, I think there are a few others as well, but that's the one I know.
Cool. All right. And so our second question is from Adam Collar. When developing an APIs, do you recommend people build these with domain-driven design, or is there a design approach you favor, event-driven design, etc.?
That's a really good question. So Eric Evans' Domain-Driven Design was a book written about 15 years ago about building large-scale applications and getting teams to work collaboratively. And he's got a few really key elements in there. One of them is called the ubiquitous language, which is really discovering the language of the domain, how we talk about our products and services together as a group. He also talks about a thing called bounded context, which is where we set our boundaries for this is user management, this is warehouse management, and where the boundaries go. And some details about how you can actually write code inside that space to support these notions of bounded context and domain language. So those two elements, bounded context and domain language, even though they were developed for basically what are now called monolith applications, large-scale Java applications, they've become very popular in this microservice and API space. It's very often a service or an API represents a ubiquitous language and a boundary. So I do definitely encourage that. What I would say also, though, is to make sure to look outside the implementation details that Eric Evans talks about. Von Vernon has a series of books that I think are very helpful in this space as well. I think the real value of domain-driven design is to get us to think about shared language and boundary lines. And both of those cases, that's not scientific. That's very much social and very much creative. So I think those are really keys to that story. So I do recommend Eric's book. I have it on my shelf and I refer to it quite a bit. And what I recommend are these two key elements to the story that you can apply to APIs and services. So that's a good question.
Yeah, and as a follow-up to that, this is from Adam as well. And I'm not sure if this is covered in Eric's book, but he says, is there something you can recommend to help people understand the scope and boundaries of an API when being designed?
Boy, if I did that, I would be a billionaire, right? It's a real challenge. Here's my experience. Here's my honest experience. When I first start designing APIs with a team, often I'm sort of the new kid in town. I don't understand where the boundaries are, and there has to be a lot of explanation. A lot of times the boundaries are literally in our heads. We've sort of internalized them. There's an old joke, cartoon I see. It's two fish. It's sort of a younger fish and an older fish. And the younger fish says to the older fish, okay, explain to me this thing called water. What happens is we don't think about it because we're around it all the time. So often the very first boundary you draw is not quite correct, but you still need to release the software. So I think one of the things I teach people is you'll not get boundaries right the very first time. Eventually, you'll home in on the right boundaries, but it's a real challenge. Now, another way that I think helps people understand how difficult it is to figure out where a boundary goes is to actually get them as a group, get all the stakeholders as a group to start talking about the same thing. And they have a real hard time. They call it different, they have different names for things. They have a different understanding of how it works. And a great set of exercises for doing this is event storming from Antonio Brandolini. Event storming, Antonio Brandolini needed to teach people how to create boundaries and understand how processes flow in existing systems. So he created this exercise that has a lot of different colored sticky notes and a large board. If you just look up event storming, you've probably heard of it, but you could look it up and you can read about it. And that starts to bring home the complexity of deciding where to draw the line. Hopefully, I'm not sure if this helps, but literally I draw lines, I show them to people, they argue with me, I change the lines. We eventually pick something to release because we have to release this quarter, and then we fix it later. That's literally the experience that I have. Hopefully that helps. Let's see.
I'm sure that sounds like a very good answer to me. So our next question comes from Tim Laverne, and he says, what do you see as the main challenges in use case development for microservices?
If I understand the question, and Tim, you can correct me here. This really has to do with, so a little bit like the scope question, right? Is like, how do you develop the use case? How do you there are a couple of steps, right? How do you identify, how do you describe and document, and then how do you implement, right? So here's some of the things, and hopefully I'm getting close. And Tim, you can jump in here. One of the big challenges is creating a use case that's too generic. Like the use case is, I need to read and write data. Well, everybody needs to read and write data. The problem is it gets pretty difficult to know who your users are, who your community is, and what data they're reading and writing, right? So SQL as a service or database as a service is not really a big value add for your organization. There are lots of data storage systems. So the next challenge is to get beyond a sort of just general idea of I need an API platform that does all these things, and to start to solve real problems. So my real problem is that I need to store data in a certain amount of time in a certain way from some certain customer, right? So now we're getting much more specific. Now there's a pendulum swing, right? So if I design a service, if I get a use case for a service that solves one customer's problem for one instance or one use case, I'll never reuse that service, right? So the opposite is also a challenge, and that is to design use cases so specific to a particular instance that no one else can use them. And then you get a really low reuse value, which is a target for a lot of my customers. They want not just use, but they want reuse. They want to be able to use it again. So I think figuring out what the sweet spot is in that is one of the big challenges. I don't want to be too generic. I don't want to be too specific. Finally, and I talk about this in another series that we didn't have a chance to mention, and that is that I need to understand that I'm solving customers' problems, not my problems. They don't need to know anything about my database or my data model or my object model or my latency issues. They need to solve their problems, right? So that's the Clayton Christensen jobs to be done pattern, which is understanding that I just want to hang a picture. I don't really care about your drill. I'll buy one if I have to, but I'm really hanging a picture. Make my life better by making it easier to hang that picture. So sort of going beyond whatever the particular technical detail you have is in solving the other team's problem or solving the customer's problem or solving the other division's problem is, I think, the really valuable use case. I'll end with just this one item from Adrian Cockcroft, who was the cloud CTO at Netflix. And he said when they were trying to transform their organization, they would look for the smallest problem that would teach them the most, and they would fix that first. In other words, they looked for a problem they already had. They didn't invent a problem. They didn't build something out of whole cloth. They looked for a problem they already had and fixed that. And they looked for the smallest problem. They look for the smallest problem because that's the least amount of risk, right? No big bets. You're not going to transform the entire organization by next year. Pick the smallest thing you can learn from, fix that. Pick the next smallest thing and the next smallest thing and the next smallest thing. And suddenly you've got a transformational organization. So hopefully those will give you some ideas. I'm not really sure.
Yeah, Tim says, thanks, you answered my question. So
Okay.
good job.
All right.
Does anyone have other questions? I know Mike has been just phenomenal, but
I've
we
been
might as
talking too
well
fast.
we might as well use him while we have him. So let's have some
I'd
more
be happy.
questions. Yeah.
Even if it's something that wasn't, in my slides. If I missed something, if I didn't talk about something that you're interested in, give it a shout out. I'd be happy to try. Let's
You
see.
can also use the raise hand feature if you want to
Mm-hmm.
talk directly with us.
Mm-hmm. Be happy to do that.
Maybe one question while
Mm-hmm.
while we have you here and people are thinking of questions, Mike, is this is a fluffy one, but one I'm always interested. You've traveled so many different places for your work. What's one place that you're really looking forward to going back to?
See, that's a dangerous question. It's a really good question. You and I talked earlier about this. Before the pandemic, I traveled 30 up to 40 weeks a year. I was traveling all over the globe, and it meant I could meet lots of really amazing people. And I met them in all sorts of places. I haven't been traveling, so it's been harder to interact. We do this sort of digitally now. There are definitely places that, there are certain times of year. There are some key events in Paris in the fall that I usually go to Paris, and I've missed 2 of those sessions now. I'd love to get back to Paris. I've got some great partners in Tokyo that have been working on some amazing projects, and I haven't been there now for 2 years. I'm very anxious to get back. Some companies in Australia. These are all places I would love to go. So
Wonderful.
I'm hoping that there'll still be some opportunities ahead, but I suspect I won't be traveling as much as I used to. It's probably time for me to kind of slow down a little bit. I've been enjoying, as we kind of said earlier, I've been enjoying sleeping in the same bedroom for like weeks at a time. That's an amazing experience. I love being there. I don't like getting there. So I'm kind of getting spoiled. So I'm hoping
You need
I'll
to
be able to come up
invent
with
an API for just time travel.
That's right. If somebody would just solve that problem, I'd be
Terrible joke. All right. Well, it does look like we have a couple more questions here. Thanks, everyone. So, one question coming from John Kingsley says, "I'm
Okay.
curious about multiple data locations. StreamWrite. Any
Yeah.
examples?"
Well, yeah. So think about the way a product like Kafka works, right? Or any of the related sort of data streaming services. Basically, these are services that are geared for writing lots and lots of data and resolving differences later. So lots of people could be adding records to a system. So there are lots of examples of these kinds of things, or staging copies of servers in various locations. And then resolving the differences later. This has been going on for quite a while. I'll give an example. I will just say a very large, an international cosmetics company. Their main offices are in Europe, but they have key administrative services in the United States. And they need to be able to access the same data. It turns out there's a whole set of corporate and product data that doesn't change very often, like it doesn't change by the second, but it might change every day. So what happens is that data is managed by people in Europe. So the team in Europe makes changes to that all throughout the day. And at the end of the day, that mostly static information gets updated or copied to all sorts of places, including the one in the US. And the US always accesses its local copy of that data. So this goes on in lots and lots of places, and there are whole businesses which are content delivery networks, which basically do the same thing. So that's one of the examples. Now, as you get more towards real time, that example of caching copies of data in various locations, maybe updated a few times a day, doesn't work when you're on the trading floor, right? When you're on a trading floor for commodities. So that's a different set of challenges. So the trading floor for commodities, I need to know that there's one machine that I operate on, and it needs to have some level, some SLA that basically says the information that's kept in this data store is no older than X number of milliseconds from when it was first generated, right? So you set up these different SLAs. So there's some cases where it has to be accurate within milliseconds, others where it needs to be accurate within minutes or hours, others where it needs to be accurate within hours or days. And you stage these various machines. I think this is a little bit about where data lakes and other things come from. The idea that data is singular really has kind of gone away. There's this notion of rivalry. Data is non-rival. I can sell you a copy of my personal data, and I can sell somebody else a copy of my personal data. I don't just sell it once, whereas if it was a physical good, if it was rival, I can only sell it to one person. So not only is data non-rival, can I sell it to lots of people, data actually exists in lots of places. And we need to start constructing our architecture around the idea of this idea of multiple data. Hopefully that helps.
Awesome. Okay, so our next question comes from Kevin Faulkner. Mike, I'm not totally sure if you're going to be able to speak to this, but the question is, what are some companies that use Synergy DE using to update or modernize their GUIs nowadays?
Yeah, I can't really speak to the product space. Maybe there's someone else online here that might be able to answer that. Is Kevin's question, but I'm sorry.
If anyone from the Synergex team wants to raise their hand, I can certainly enable your microphone. But while we're getting that possibility of an answer put together, let's move on to a next question. So this comes from Andre LeBlanc, and he says, what about versioning? What do you suggest for not breaking your customer call between updates?
Yes, this is great, and this actually is related a lot to the data question that we were talking about before. We've lived in a world where there was only one version. You know, when I built mainframe and mini computer systems, there was just one version running and everybody ran it. Any changes I made, everybody got to see the changes right away. But we're not living in that kind of world anymore. We're living in a kind of a headless world where there are lots of parts that are interacting. So versioning is a big issue. Versioning of data. So versioning of data is when data morphs, data changes, evolves, when the structure of data changes, and so on and so forth. Versioning of functionality is the same thing. When the ability to compute particular figures, net present value, so on and so forth, change over time. And versioning of solutions. In other words, the way we solve a particular problem, a handheld application, a browser application, a desktop application. All of those have multiple versions in them. So we need to really think about versioning as a way to manage change. It's really just a technique. And the versioning technique is to simply give it a new number and tell people, go use this one instead. The challenge you have is as your global reach expands, you can't get everybody to adopt the same software on the same day. You can't just shut off the lights on Saturday, update all the computers, and turn them on Monday morning. So instead, you have to operate in an environment where there's a lot of heterogeneity, where there are lots of versions of your software running at the same time. This is essentially what the web does. Your browser is not the same version as my browser, and yet they both operate just fine. The versions of HTML are different. The versions of HTTP are different. The versions of the applications running in them are different. So what you need to do is you need to set up a system where multiple versions of the software coexist side by side. There's a company that does this rather well, and it's Salesforce. So Salesforce releases new software every 4 months, and they release a whole new set of software, and they say you can start using the new version of software whenever you want to. However, since they do it every 4 months, they've been at it a while. I think they're on version 50 something. They support about 20 versions backward compatibility. So I know they support something like, they're on 50 now. I think they support like version 32 and ahead. That's a huge expense to have that much of an ecosystem running. Most of the customers I have can't support 20 versions. But you need to be thinking about the idea of multiple versions. The other thing you can think about is changing for forward and backward compatibility. There are 3 rules. I'll just end with the 3 rules. If you want to put out a new edition, you can't take away something that you promised. You can't take away a URL or a feature. You can't change the meaning of an existing one. The third argument meant page count. You can't make it mean user count. And the third one is anything that you add has to be optional. So any new arguments for a form have to be optional. Any new responses back have to be optional. So if you can follow those 3 rules, That's what TCP/IP does. That's what HTTP does. That's what HTML does. That's what browsers do. And that's how you can get ahead. So managing change over time is what all of us are going to be doing. And the biggest one is this notion of having multiple editions or multiple versions coexist.
Awesome. Fantastic answer. I do have a guest question answer, Steve
Okay.
Ives. If you'd like to unmute yourself, Steve, obviously from our Synergex team, I'm sure many of you will know him quite well. Can help us answer the question about updating GUIs.
Yeah, can you hear me?
Yes, thank you.
Okay. Yeah, I just wanted to quickly address Kevin Faulkner's question about the companies using Synergy to update UI. Kevin, I'm not sure we can get too much into detail about specific companies in a forum like this without their permission first. More than happy to have a discussion with you offline about that. Also, I would point you to the session on Thursday morning at 8:30. The title of that session is Leveraging Web Services for UI, and there will be demos from two companies. I think Bill did mention those companies. That's Radley and Forward Computers, both of whom there'll be a demo element of exactly what you're talking about. So let's start there. And if you need more from us, then by all means, let's get back together after or offline.
Yeah, and another plug. Thank you, Steve, by the way. Another plug from Don Fillion, who's our VP of Professional Services for the Thursday morning session, which will be really, really wonderful. So thank you both for that. And Mike, we have 3 minutes left, so I think that we have time for one more question.
Okay.
And so we have one from Tim Laverne. And this one says, how do you deconflict changes to multiple databases that overlap?
Yeah, so the good news is I don't know, because there's lots of mathematicians who do. There's this thing called consensus protocol, which kind of operates a lot on date and time and in like record consistency, that can handle most of this for us. A good example, again, I'm going to use the sort of the canonical example, literally the Kafka data store systems do this quite a bit, but lots of other systems do this as well. If you think of the way Git and GitHub work, they also do conflict management at the individual byte level as well. So luckily, there's a lot of technology there. The real challenge, I think, is not actually at the individual record level, but it's at the sort of semantic or at the object level, how you get consistency. The way the web handles this is there's a process called tagging, entity tagging, where when I send you a record, say this is my identifying record, I have a little key that is sort of like a hash of all of the data that's in there. It's a sort of a validator. When somebody tries to edit that record, they need to hand back the key. If the keys don't match, then I prevent somebody from overwriting. And then I say, okay, you need to go ahead and get a new fresh version and come back. So you actually manage the conflicts that occur. In Git and all that, those are called merges, right? You have to do a manual merge. So the same kinds of things exist in data. There's a gentleman by the name of Rich Hickey who created a data system that I can't really remember right now. Somebody else may be able to remember it. That was totally built on this notion of how you do this conflict management, and it has a lot to do with having the idea of time and having a series of values for the same field. In other words, you don't overwrite the field. You have a series of values the same way Git works. So there's definitely technology that's out there that does that, and you just need to kind of find somebody in the data space that works in consensus protocols and works in conflict management, and then start inspecting their product. That's literally what I do.
Wonderful. All right. Well, we are just right at 9:30 or 12:30 or whatever time it is for you. So we're gonna end this session. But Mike, thank you so much for the wonderful presentation and thoughtful question and answer session. You're fantastic, and we really appreciate you being here today.
It was my pleasure. Thank you very, very much. And I hope it was helpful. I've enjoyed it, and maybe someday we'll get a chance to meet in person sometime.